In this lecture, I will be providing a simple model for understanding option valuation, and it is the binomial option pricing model. And in particular, I will be interested in the two-state version of this model, so two-state option pricing. In general, option pricing formulas are very complicated, and as such, this model, this two-state binomial option pricing model will provide a simple first step into this difficult subject. All right, so the understanding is that we have a stock which is currently selling at $100. So let the stock price S sub 0 currently selling at $100, and in our two-state world, we believe that this stock next year, a year from today, might have one of the two possible values. It will be either the value will go up to $120 or it will go down to $90. And for that, we even use kind of some notation, and let me, if you guys want, introduce you to that notation. It is just, if you call this, instead of S0, let's just call it S for now. S times U. So U is the up factor. So we have two potential paths. So on the first path, the stock price can go up from 100 to 120. And so the factor U is simply equal to 1.2. On the down path, again, we will multiply S 100 times D, where D is 0.9. Okay, let's go ahead and write these. So 100 times 1.2, the up path, and then the factor for the up path, and then the factor for the down path is 0.9, and as a result you get the $90 and the $120 respectively. But when that's the stock price, then the corresponding call option will have well, the question is, what is the value of the corresponding call option with the following features? That call option will have a strike price of $110. So let's write that down. Let's do it like this. So just give me a second. So we want to find the value of the call option where the strike price is $110, and it will again expire in 1 year. So therefore, C, the value, whatever it is, which is we want to derive, assuming that the underlying stock has the following two-state diagram, two events, potential events for the following year. The implication for the call option would be when you buy a call option and the stock price ends up at $90, the call will go worthless, because the call option gives you the right to buy the stock at the strike price of $110. Why would you buy the stock at $110 if it is currently selling at $90 at the marketplace? So therefore, at the down node, the call will go worthless. Versus at the up node, we know that the stock will be, right now, the underlying stock will be selling at $120. So what I can do is I can exercise my right, and I can purchase the the underlying stock at $110 and immediately flip it and sell it at the marketplace for $120 and making a direct $10 profit out of this transaction. Now the main question is again, how should I price this call option before year one, or to be exact, in year 0. So we know the stock price in year 0. What is the call price in year 0? Well, what is the neat idea of the Black-Scholes model is the fact that the result will come out to be independent of the individual probabilities of those paths. So the up node, the up path or the down path their respective probabilities is irrelevant, and that's perfect for us. And so this and with this idea, this is the results are very general, and it directly helps us price the call options, or the put option for that matter. So how does it work? Well, the main idea is to come up with a replicating portfolio. So we will create our first replicating portfolio, and for that I'll go ahead and create two examples actually. In my first example, let me go ahead and create portfolio A. And portfolio A has two pieces in it. We will in the first one, we will purchase one share of stock. Okay, let's write that down. One stock, and we will also borrow some amount of money. So borrow money, but which amount? So the amount will depend on the interest rate at the marketplace currently, and let's assume that the interest rate is 10%. So an assumption that is given to us early on in the problem. So the interest rate is for borrowing and lending money is 10%. So what I will do is I will go ahead and I will discount in the $90 basically at the 10% rate. So that will be the amount that I need to be borrowing. So I will be borrowing equal to the amount that I will be borrowing would be equal to $90 divided by discounted at the 10 cents, 10% I should say, 1.10, and that should give you $81 and 82 cents. Okay, so with this amount of borrowing, now we can realize that the cost of portfolio A, is simply equal to, well, we purchased one stock, which will cost us $100, but at the same time we borrowed $81.82, so we need to subtract this amount, $81.82, for a net cost of $18.18. So the overall cost of this portfolio A is $18.18. And what is the outcome? What is the final outcome of this this portfolio? Well, to start with, so again, my portfolio will have two states in period one. Either the stock price will go up to $120, so therefore my stock is worth $120, and yet I need to return this principal, the amount that I borrowed, plus the interest, so it will turn out to be $90, so therefore minus 90, so that would be equal to $30. So therefore at the up event, we have, if the stock price goes up, portfolio A will have a value of $30. What happens if the stock price goes down? Well, my stock will be worth only $90, but then the loan still has to be repaid with its interest, again $90. That one won't change, and as a result, at the down state, the portfolio will be worth $0. So our portfolio in the up state is worth $30. In the down state, it is worth $0. Compare this with this call option. I think it is clear that the portfolio is just 3 times the call option. If you purchase 3 call options, each call option in the up state giving you a payoff of $10, in the down state going worthless. So it would be clear that combining these two, so let's call this one as star, this one as double star, we can say that, and let's just put a line here, so star and double star would simply imply that in state 1, the two are, so the portfolio A is just 3 times the call option, so therefore in terms of the cost, it must be 3 times that as well. So therefore A is equal to 3 times the call option. And that's it. I already know the cost of A. Does that make sense? The cost of portfolio A was 1818. Let's write it this way, actually. Or for the time being, let me leave it like this. So A being equal to 3C means the way in state at year one, if you will, at year one, in terms of the outcome at year one. So therefore, by the no arbitrage opportunity, their costs should have been equal as well. So by a no arbitrage principle, the costs of constructing these two constructing the A portfolio and the 3C constructing the A portfolio and 3C, meaning purchasing 3 call options, should have been equal. And that's just a consequence of the no arbitrage principle. But wait, we already know the cost of portfolio A, building portfolio A, and we clearly marked it as $18.18. As a result, 3 call options should be worth 1818, should have a cost. So therefore, 3 call options should cost 1818, implying that an individual call option should be worth $6.06. And that's it. We were able to decisively price the call option without having any knowledge of the individual probabilities of the stock price going up or down, right? So that's just an amazing result, directly following this replicating portfolio, constructing an alternative portfolio with the same payoff in year one, and boom, so we get the result. So let's have a look at one more time on how we constructed this portfolio. So basically what we did is we purchased, so this one is a purchase, right? We purchased a stock and we borrowed some money. So if you will, you can think of borrowing money as a bond security, and purchasing the stock is related to the stock again. So combining a stock and a bond, we somewhat created a synthetic call option, right? If you will, you can say that 1/3 of this portfolio A is exactly equal to the call option. So what you can do is you can purchase 1/3 of a stock and borrow 1/3 of this money, and this would have been exactly equal to the call option. But for the purposes here, that would have been so instead of doing that, like instead of breaking this into 3 pieces each component, we just went ahead and created 3 call options, which is fine. Well, there's an alternative ways to do that. So this time I want to go ahead and basically purchase stocks again, but instead of borrowing money, I want to write some call options, and I claim that replicating the portfolio in this way as well would give me the ability to price the call option as well. So here's an alternative solution basically. So let's scroll down, let's draw my line, replicating portfolio B, replicating portfolio. In this case, I'm not going to replicate the call option directly. Instead, in a sense, I will be replicating the bond security. So therefore, I will be creating a portfolio which its payoff in year one would be independent of which path you took, and it would be a fixed number. So my replicating portfolio B will consist of 2 things again. Okay, so it will consist of let me first write down the numbers, and then let's explain where those numbers came from. So I will go ahead and again purchase 1 stock. So purchase 1 stock, one stock, and I will at the same time write, not purchase, but sell, write 3 call options, or 3 options. And let's investigate again the binomial tree, and or before I do that, you might even consider what will be the cost of this. Let's first calculate the cost. Well, the cost of building such a portfolio, because I'm purchasing one stock, I need to pay $100, obviously, minus, because I'm writing 3 calls, I will get 3 times the call price at time 0, right? Because I'm selling those, I will get the proceeds. As a result, the cost will be reduced. So we have this portfolio. What will happen to portfolio B in the next period? Well, in the up state, when the stock price goes up to $120, well, because I purchased a stock, that would be $120, minus, in the up state, remember that the call option expires in the money. So as a result, it will be 3 times $10, 3 times $10 for a $90. In the down state, well, the stock a year later will be worth $90, and the 3 call options that I wrote will expire worthless, so which is good for me. And wow, look at that! Regardless, the portfolio B, independent of the stock price in the next period, always give me a $90 outcome, which is pretty good. So and this is so I can compare this with just borrowing, right? So we can just compare this. So this thing is directly comparable. Let's write that down. Compared to borrowing. Well, actually, I should say lending. Sorry, compare this to lending, because we have a positive cost here, so we are actually spending money. Compared to lending, well, how much should you lend so that a year later you can get $90? And that would be just 90 over 1.1. So compared to lending, well, $90 divided by 1.10, and that would be exactly $81.82. And this you might remember this from here, and that's pretty good. And obviously this $81.82 will be expiring a year later. You will be repaid the principal plus the interest, which they will add up to $90. Now these two, the portfolio B and this lending business, should have exactly the same cost, because in year 1 they have the same outcome. And by the no arbitrage principle, so by no arbitrage, let's write that down. This is an important one. Arbitrage principle. These two should have the same value, right? So the lending and portfolio construction of portfolio B should cost the same. At t equals 0. And obviously we already know the cost of portfolio B, which is $100 minus 3C, and the cost of lending would be $81.82. $81.82. Now we can solve this for C. That will give us 3C is equal to 100 minus 81.82, which is just 18.18. And again, we come up with the same result, $6.06. That's pretty neat. So we came up with the same result earlier. So regardless of the way you replicate the portfolio, either be it in the first one, in portfolio A, I replicated the call option itself by combining stocks and bonds. In portfolio B, I combined stocks and options to replicate a bond, and yet you can come up with a third replicating strategy, where you combine so options and bonds to replicate a stock, for instance. And even in that occasion, the call option should have the same price. So please do it as a homework. So let me write down the homework. Construct yet another portfolio, say portfolio C. Well, actually, portfolio C will confuse with the letter C, which I used for the call option. So let's say D. I'm going to use it in a second. So say E. E is good, where we combine bonds, borrowing or lending, and options to replicate the stock. And this is possible as well. And from that, you should be able to get the same call price as well. Okay, so one idea which is not clear, the first replicating portfolio was very straightforward. There was nothing surprising. But the second one, there is one idea which is kind of unsettling. And this is the idea of why 3 call options. Why 3? So why do we combine one stock, purchase one stock, and sell 3 call options? Now, why not 2 call options, and so on? Well, the number 3 is actually comes directly from a strategy called delta hedging. So let's write that down, and let me mention what it means, and then we can probably stop with that one. So delta hedging is, one of the Greeks is delta, and delta will just give the sensitivity of the option value to the changes in the price of the underlying asset, the security, which is the stock that we have. And for our example, in this two-state binomial model, the change, okay, let's write that down, the change in the call value divided by the change of the stock. Well, we just realized early on when we did draw the call tree here, binomial tree here, we realized that the change in the variation in the call at year 1 is the payoffs is $10 minus $0 in the up and in the down states, and the variation in the stock was between $120 and $90. So basically we can just go ahead and calculate the delta as C on the up state minus C in the down state 1 year from today, divided by U times S sub 0 minus D times S sub 0. And that's it. And so that's equal to, so like I said, $10, the variation in the call value a year from today, call payoffs, if you will, and then divided by the variation in the stock prices a year from today, and this is equal to 1/3. Aha! So this is the delta, which is one of the well-known Greeks, arguably the most important Greek of a derivative, and so we have this 1/3, and that's kind of the idea behind purchasing one stock and 3 call options. In fact, alternatively, we could have purchased 1/3 of a stock and write 1 call option instead, and that would have given us exactly the same answer. And if you will, and that's the idea of the delta hedging pretty much. So let's do it. So purchase 1/3 of a stock. Consider the following portfolio, which is basically the same as the one I did earlier, but slightly different. So in your portfolio, you have 2 things. Purchase exactly this amount. So 1/3 of the stock, and sell or write. Maybe I should say write instead. Write 1 call option. Again, the cost of this, the cost would be equal to, well, purchasing 1/3 of a stock will cost you 1/3 times $100 at time 0, minus, well, this cost will be reduced by writing this call option, which I will receive as a writer by selling this call a premium, right? And that's what we are pricing actually, minus C. Well, what we can do is we can check the payoff of such a portfolio. So my portfolio, the payoff would be, well, in the upstate, that stock that I purchased will be worth 120 times divided by 3, because I just purchased a third of a stock. So that will give me only $40. And writing the call in the upstate will cost me money, obviously. It will cost me $10. Minus $10 because it will expire in the money, and so that will be worth $30, versus in the downstate the stock will be worth $90. A third of it is $30 minus the option will go worthless, and again $30. Aha! So a year later, with certainty, we have a position where we have $30 with certainty. So we could have created, alternatively, we could have created this portfolio simply by lending money, right? Alternatively, lend money, well, how much do we want to lend? We want to lend $30 divided by 1.10, and that would have been $27.27. And as a result, a year later, we would get exactly $30 after compounding of interest. And now we are ready to compare these two. So the cost is $27.27 of lending $27.27. So basically 27.27 is equal to 33.33, a third of $100, minus C, implying that C is equal to $33.33 minus 27.27, which is $6.06 again. So that's the main idea behind delta hedging, and it's a pretty neat idea. Like I said, we are using the no arbitrage principle. Here the principle was effective in this arrow when I pointed this. The main idea that worked here is the no arbitrage. If two different investment opportunities have the same payoff in year one, which is $30 for both of them, both the portfolio here, which is sure $30, versus lending enough money so that you get $30 a year later, the two have the same outcome, payoff in year one. As a result, in year zero they must have costed the same amount, which is $6.06. So let me stop this first part of my binomial option pricing lecture. In the second part, I will go ahead and we will talk about how what happens, how can you benefit if the option was mispriced, either overpriced or underpriced. How can you use arbitrage, the no arbitrage principle? How can you arbitrage it, to be honest, so that you can, with certainty, you can earn money without costing you anything. All right, so see you guys in the second part.